In this video, we're going to solve part D of question 10. In this part, we want to find the y-coordinate of R such that A is a maximum. To find a maximum for A, first we want to find a critical point for A, which is a solution to dA dx equal to 0. So, first we solve dA dx equal to 0. This implies that 9 minus 3x minus 2x squared over square root of 9 minus x squared is equal to 0. For a fraction to be 0, it is equivalent that its numerator is 0. So it is if and only if 9 minus 3x minus 2x squared is 0. Because we don't like the negative coefficient in front of x squared, so we take a negative 1 out. So the equation becomes negative 1 times 2x squared plus 3x minus 9 is 0. Okay. Then we want to solve this equation by factorize the quadratic polynomial on the left. We can use the cross method. So we write the x and y here. First we decompose the coefficient of x squared. And there's one way to decompose 2. It is either 1, 2 or 2, 1, but they are the same in this case. And then we're gonna decompose negative 9, the constant term. Alright, so you can decompose the negative 9 into negative 1 times 9 or negative 9 times 1 or etc. But you'll see that this won't make the coefficient in front of x 3. So the better way to decompose the negative 9 should be negative 3 times negative 3. And in order to get positive 3 in front of x, the negative 3 should be in this upper position, and the 3 should be in this lower position. Indeed, if we make this decomposition, then the coefficient for x will be, so here, the result here should be 2x times 3 minus x times minus 3. It is 3x. This is what we want. So our decomposition is negative 1 times 2x minus 3 times x plus 3 equal to 0. Alright, so this implies that x is equal to 3 over 2 or negative 3. However, from the assumption, we know that the points Q and R are in the first and the fourth quadrants respectively. So they must have a positive coordinate. So x here now is their x coordinate. So x has to be positive. This implies that x must be 3 over 2. Because Q and R have a positive coordinate. Okay. Now we want to check that 3 over 2 is a maximum. Okay, recall that the maximum only happens in critical points or the boundary point. So here x actually has a range because now again Q and R are the points in the first and the fourth quadrants. So this means that x has to be greater than or equal has to be greater than 0. Also, because Q and R lie on the circle. This means that the x-coordinate of Q and R can't exceed 3. The point here, the rightmost point here is 3, 0. So the x-coordinate of Q and R cannot exceed 3. This gives the range for x. So because, again, Q and R are in the first and the fourth quadrant. And also lie on the circle. Therefore, x has to be greater than 0 and less than or equal to 3. Okay, so now let's plug in x equal to 0, x equal to 3, and x equal to 3 over 2 into the function to see which is the maximum. Alright, so now we compare a of 0, a of 3, and a of 3 over 2. Okay, so a of 0 is, so from part B, we have calculated the expression for a. Let me recall it. So a of x is equal to square root of 9 minus x squared times x plus 3. So a of 0 should be square root of 9 minus 0 times 0 plus 3, which is 3 times 3, which is 9. And then we calculate a of 3, which is square root 9 minus 3 squared times 3 plus 3, which is 0 because 3 squared is 9. Finally, a of 3 over 2 is equal to square root 9 minus 3 over 2 squared times 3 over 2 plus 3. So it is equal to square root of 9 minus 9 over 4 times 9 over 2. It is equal to square root of 4 of 36 minus 9. Sorry, square root of 63 minus 9 over 4 times 9 over 2. So it should be the square root of 25 over 4 times 9 over 2, which is equal to 5 over 2 times 9 over 2. This is 45 over 4. And this is greater than 9 and 0. So we got the inequality. A of 3 over 2 is greater than a of 0, which is greater than a of 3. So this tells us that 3 over 2 is a maximum. So or a of x has a maximum at x equals to 3 over 2. Okay, but now we want to find the y-coordinate of r. And the y-coordinate of r is negative y. So because y-coordinate of r is equal to negative y, and from part A, we know that y is equal to square root of 9 minus x squared. So negative y is negative square root of 9 minus x squared. And then we plug in x equal to 3 over 2 into this equation. We'll get negative square root of 9 minus the square of 3 over 2, which we have calculated in the previous calculation. Or it's not hard to see it is equal to 25 over 4. So the y coordinate of r is negative 5 over 2. That's the answer for part D.